Buongiorno, Trieste. También podemos hablar español. That's why I can speak a little bit of Italian and understand you guys, because my mother tongue is Spanish. So welcome to another event of another edition of Box a Days Trieste. And the topic of today is going beyond ORMs. My name is Almiray. I work for Oracle, and I like to talk about a lot of things, specifically things that will help you guys, you folks, in when you are developing mostly Java applications. But if you happen to use any other languages, the feature that I'm going to showcase today should also help you. And one of the things that I like to do is just travel around the world and talk to you and to talk to folks about open source, about methodologies, about tools. And I do have stickers, by the way, in case that you would like to talk about JReleaser or a few other things. But, so for today, this is the agenda. And I know that when we are writing applications, at some point in our time, we have to talk to a database. We know there are many variations, there are many vendors, Oracle happens to be one of those. And when we are dealing with data, it's very likely that we start talking with relational data. But for many years now, we are also been using other formats that are non-relational, right? JSON, or it's columns-based, or something else, right? There are advantages of using either of those two or those two together. So what we'll see today is a way to combine relational data and document-based data, which is JSON-based. And we'll end up talking about a feature called JSON Relational Duality Views, which is available in the Oracle database. And I will showcase also how you can make use of this feature very, very easily. Okay. So, of course, I'm going to talk about the Oracle database, and there's likely that at some point in your time you have to use this database because it's one of the database that scales the most. It has lots of features. Again, it's not the only database vendor exists out there, but I think one of the reasons I like this particular database is not just because they pay my check, but also because we have this feature called the convergent database. Other vendors call this a multi-model. What is a multi-model? Hold on a second. Well, it basically allows you to use different storage formats inside the same database engine. So you can use relational or JSON documents or graph, spatial. Nowadays, vector is all the rage. So all these different formats in the same engine. Some of these vendors will allow you to query across the formats in an easy way, and some others will force you to go one level up into the application layer. Regardless of that, you will be able to combine data using different formats. Well, the database provided by Oracle is the one that gives you the most formats compared to the other competitors, and also gives you access to a single query language across all different formats. You don't have to go up to the application level. You can still do it on the database layer. So when you start writing an application and you need to deal with the database, it's likely that we're going to start with a relational model. So we have a very trivial application, I know, but this can grow to many, many different relations and tables. So say that you want to define the model for a simple conference. And you may start by describing the model for an attendee, a session, and a speaker, and they will have some M2M relationships and one-to-many and whatnot, and each one of them will have different properties that will map to different columns, and you would choose the different types and whatnot. So we start with something that is with a mental model of how the objects in the real world behave or they relate to, and we put those into relational data, right? So we know this by heart. The advantages of using relational data is that you can have a normalized model. So these are well understood. There are many tools that know how to go from a not very normalized model into a fully normalized one. Once you have relational data, you can have a very good reporting capabilities, and you have data consistency. There are many reasons why you would like to do this. The problem with relational data is that you had to come up with this model up front. So you have to think about this at the beginning, very early on. And yes, I know there are things like database migrations where, oh, I made a mistake, I need to rename a property or add a new table or add new columns and whatnot. Yes, we can use migrations like Liquidbase and Flyway and some others. Sure, but you still have to think a little bit upfront on what needs to happen. So there's a little bit of investment that you have to do in order to transform this abstract model of domains and entities, real-world objects into relational. And there are some of us, that used to be my case for many years, where I just don't want to deal with SQL. I understand the language, I just don't want to use it. I would prefer to use my own programming language, right? So that's why we have these big ORMs, so that like Hibernate or JPA, so that I can continue using my programming language of choice, and that will magically do the mappings and transformations into my programming language into SQL or some other language that is understood by that database vendor, which happens to be non-relational in this case. And then that thing that is not my programming language will be hidden away. That complexity will be hidden away. That's what I want, right? But these ORMs can become a burden at some point. They can be very heavyweight, and sometimes these mappings will have issues like everything else, will have bugs, and we will get into trouble, just like everything else, right? So if I'm writing this application and I want to have these attendees and speakers and sessions and this mapping with all these things, at the end, what I would like to display in my app, whether it's a mobile or a browser, is some sort of card where I get all the information for all these different models, for all these different entities in one go. Maybe it's one page, is one virtual card, whatever it is, right? So this is what we would like to do. But in order to make this work, we'll either have to issue different SQL statements or talk to our ORM to figure out how we can get that data out from different tables at the same time, or one after the other. Okay. So if we were to render this information as a JSON document, remember, we're starting with a relational model. We have many different choices. Whether we can put this into a set of nested elements, we can choose which one will be the root, where it's going to be the attendee, where it's going to be the session, will it be the speaker, will it be the conference. It's up to you. In this case, we have chosen the attendee. And in case of the attendee, when we want to display the schedule for that given attendee, what they have chosen, you can see that it has embedded elements for the session and the speaker. And as a matter of fact, the speaker itself has been lifted and be associated with the session itself instead of being a nested element. Or we can do it in this way. When the session is the topmost element, now we get an array, or we get a list of session objects where the information of the speaker and the attendee are combined as well. Or we can do it this way, right? So you have many different choices to represent this relational data as a set of documents. It's up to you based on your requirements. Now, the good things about JSON is that we can start very quickly with this. You can just start mapping in the way that you define. Mobile browsers and just the regular browsers will accept JSON very easily. This has been happening for what? Since we got the Ajax revolution in 2004, so it's pretty much 20 years ago. Does anyone remember Ajax? Yes. Oh, wow. There's plenty of you, my people. Who's new to this set of conferences? Who's attending Box Days Trieste for the first time? Hey, just a handful of hands. Perfect. Glad to have you here. So when we started doing documents and producing this information on the web, it started with XML. And now we have JSON, and it's much better. And some people would like to use YAML as well. But the good things about JSON is that you can just throw data as it is, and the other side of the wire will understand it. And you can mutate your model very easily without having to create that schema up front that we have to do in the relational world. So you can add properties, remove properties, nest, unnest elements And it's very likely that the other side of the wire is going to understand what you're doing. Very, very easily. Now, what is a problem with JSON? Well, there is a lot of duplication in a document, very likely, because you are dealing with the direct data as it is. We're not dealing with ways to remove that duplication. So that will be normalizing a JSON document. So if we start with a document where you see on the right-hand side, we see that there is a little bit of duplication there, and we can start by adding identifiers or some other kind of foreign keys or stuff like that. So I'm using the relational terms precisely because if we start normalizing a JSON document in many different ways, we will see that we start to duplicate what we have done in the relational data. It's just that now our document, yes, is no longer redundant in terms of data, but can you understand it? Can you read it quickly? So the one on the right-hand side is very easy to understand. The data is right there. It's human readable and it's computer readable. But on the other side, you will have to do those links in your mind to find out where the data is going and why we have done it this way. So when we start doing document database normalization, we end up with the worst of everything, because now we have no schema and we have lots of IDs floating around in our documents. So the simplicity of using normalization in JSON documents is not really a nice thing to do. It's doable? Yes. Don't do that. So the problem with normalization of JSON documents is that it leads into document fragmentation. Now, instead of querying one single document that gives you all the data, which there's to be some duplication, of course, obviously, now you have to query multiple documents just to get the minimum amount of data required, right? So if you are doing this, it's pretty much as querying every single individual relational table. We just flip the format, but we are doing as many amounts of operations and database calls just to get the same amount of data. So again, doable, but it's not really user-friendly to us, the developers. We have to find a better way. Why would we like to do these kind of things? Why are we getting into JSON? Why do we don't keep using a relational, right? Well, the NoSQL revolution that happened many years ago started with exactly that idea. We don't want to use SQL. Relational data sucks. We want to use something that is simpler. Let's go with JSON. Let's go with key values. Let's use something completely different. So at the beginning, NoSQL started to say, no, we don't want to use SQL. And then people figure out, well, turns out that relational data is not that bad. It has some ideas, has the features that we would like to have. Well, we can't with the others. So NoSQL now was renamed to Not Only SQL. So what we have now is a healthy mix of relational and other formats. JSON is very simple and very easy to get started. You can just start writing properties and arrays and nested objects, and off you go. But as the complexity of our application grows, the complexity of those documents also grow, and now you start to deal with more stuff, more complexity, and then is when you realize that having big documents, whether with lots of redundant data or not, it's a big problem. So very quickly to get started, not so much when you start to get into the maintenance modes of that given application. Whereas relational, you may feel like it's a lot of effort to get started. You may feel that it's slow to get started, yes, when you have a small model. But when that model and your application complexity starts to grow, then you see that the choice of relational data was good. It gives you a lot of benefits. So the proposal is, what if you were able to start very quickly using document formats, and once the application complexity starts to grow, you can switch very easily to relational data? Wouldn't that be great? I mean, we will have to find a way to avoid storing data in duplicate formats. We'll have to find a way so that you started with JSON documents, whether with or without a schema, to translate that into relational data without losing the fidelity of the data, without losing data consistency, without losing your customers because you're saying, oh, this node has to go down because I now have to do a big migration for one format into another. We definitely want to avoid those kind of things, right? So this is exactly what this feature is, the JSON Relational Duality Views. It allows you to use both documents and relational data for the same data. We are not storing the data in two different formats and magically putting things together. We're storing the data once and allow you to use both documents and relational to query that data. So with this idea, what we want is to give you the option to start very quickly with documents, or start with some relational if you already have it, and enhance your experience. So if you have relational, you can very easily expose that as documents, or you start as documents, you can migrate to relational without much of a problem. So in the end, what is happening here is that the data is stored as relational, but the database is able to expose that as JSON. You might be thinking, Andres, this is not a problem. We've been doing this for years now. It's very easy to create some sort of view that takes a set of instructions to do mapping from relational to a document. So when we take data out of the database into a document, yeah, it's not a trivial thing to do, but databases know how to do this. What about the other way around? What about when you have a document and treat it as an input to go into the database, and that should either be an insert of a new row or of a date of existing rows, whether it's that one table or multiple tables. Someone has to understand the mapping of that JSON document and somehow create a set of SQL instructions that will affect their relational data, right? Someone has to do it. Right now, it's probably us at the application level, which is a lot of a hassle. Wouldn't it be better if the database were able to take care of this, right? Such that way that it will take care of the optimizer, and it will know exactly what to do with the query plan and do the minimum set of instructions that are compliant. That would be better, right? And that's exactly what we're doing. We have a couple of ways to define how we want to do this mapping so that the database can understand how to go from a relational world into the document and back. We can use either a JSON definition, or in this case, I'm showcasing a GraphQL definition. So when we have this sentence on the right, create JSON duality view, that's a bunch of keywords, and then we give it a name, and then we open that document, this graph definition. Notice that we have some properties like underscore ID, name, company, and schedule, and these will map to columns on the attendee table. And then we get an array of session objects. The session will map to the session table, and then we can extract some columns mapped to JSON properties for that session. And notice that we also have some annotations like unnest. So in the end, given this definition on one side, we can create documents on the other side. And again, the data is stored in a relational way where we can get a document as an output. But we can also get one document with that shape, with that definition as input, going back into inserting or updating data into the database. So the idea here is that the names of these elements that we want to put in the GraphQL definition, they will map directly to the table names. So we got attendee and the attendee sessions, which is the mapping table within attendee and the session and the speaker. And you can define the nested elements as you would like to. We can use any names for the properties, and on the left side, those are the names of the columns. There is one shortcut when the name of the exposed property is the same as the column, which in this case will be name and company. I will simply could have done just name and company on the right side and not applying another value after that. I'm using a different name for the underscore ID because that's the name that has to be at the root of the document, so that matches the MongoDB conventions. But the actual ID on the table, the column ID is a different thing, so that's why we do this kind of mapping. For the nested elements, we can supply additional hints to the database to say, when you do an insert using this view, then any nested elements should be updated or inserted or deleted. We can also have this annotation called onNest that takes one nested element and brings it one level up. In this case, the speaker name will be seen as a property on the session object. So the session won't have a nested element. So you can unnest or nest as you see necessary. So in the end, based on these relational tables that we have, so many different models that we have in our database, we can create a document like that one. Okay. We can use regular SQL calls to query through this data, or we can use document functions to query the data. Notice that we have some sort of like magic column name called data. This is the one that holds the document. The document will be realized on the go. Again, we are not storing a document. We're storing relational data. But you still can navigate that document using JSON path or any other JSON function that you have at your disposal. So what we have here, what we're proposing is that if you have an application that consumes REST, uses REST and consumes JSON documents, whether it's for writing or for reading, then you can use this feature to just store the documents as is, right? So let's send the documents to the database, and that data will be stored in a relational way. Why would you like to do this? Have you tried to do reporting capabilities in MongoDB? Yes? No? Maybe? They're not. So compared to the relational world, doing reporting on documents themselves is not an easy task. But if you're doing reporting on SQL or relational, just it's a snap. So if you can start by giving documents to your application and supplying those documents to your clients, that's pretty nice. But if you store that in a relational way, then you still have the advantage of the other format. So what we're proposing is that you keep doing that. You use that. You keep using your documents, but you don't have to do the transformations and the mapping at the application level. You don't have to ask Hibernate or the other ORMs to support JSON documents because the database is the one that's going to give you that kind of support. So the other advantages is that when you are sending those documents to the database have this optimistic concurrency control. So if there is data that has been updated under the covers while you're trying to send that document into the database, of course there's going to be a change here. And the database is able to pick it up very quickly. So either the relational changes that are coming down the covers are going to win, or your document is going to win, depending on who comes first, right? That's how the database is going to make it work. So you don't have to worry about this. You don't have to do this at the application level. The database will let you know if the query or the operation that you're trying to invoke will succeed or is going to fail because someone is changing data under the covers. So the advantages finally for this thing, again, you do documents and you also do relational. You get all the benefits of using relational. You get all the tools that keep using relational. But also, you can expose this relational information through REST means because you want to expose JSON, right? But because this feature is baked into the database and not at the ORM level or the application level, we have yet another feature or another advantage, which is this is programming language agnostic. I know that most of us are Java developers, but if you happen to need to use JavaScript or Python or Go or some other language and need to do these kind of things, well, guess what? The database is going to give you the answer because this feature does not rely on the specific programming language of choice. It's just going to work. So if tomorrow you have to use Python, you can still do a query on this relational view and you will get a document. You can set add document to the database using your regular Python SQL and it will continue to work. So now I'm going to showcase what you can use to make this work. So we have one version of the database. Yes, it is free. You can put this in testing, development, and production. Yes. And there's a URL there where you can have it there's a QR code that will give you to the URL. So you can run this on Linux and Windows without any problems. And if you happen to be like me, that have a Mac, you can still also run the database on a Docker container or Podman for free. Yes. We also have the autonomous database that runs on the cloud. And we have a free version of the database as well. If you go and sign up for the OCI Cloud Free tier, then you have access to not one, but 2 fully functional autonomous databases for free, forever. We are not going to charge you a credit card like other competitors do. This will give you access to all these features. So now you have access to that software. You can run it on the cloud. You can run it on your local environment, whether just Linux and Windows, or you can also run it on Docker, which will be great knowing that we can run these things on containers. There is a container registry, an official set of images from Oracle. There's the ADB, that's the Autonomous Database free version. There's the free version of the Oracle 23 AI, which was released just this May. And you can consume this without any login credentials, it's just go. Or you can use this one as well. These images start up much, much faster. It takes less space for download. So if you want to have a much faster experience where working with these databases, I would recommend you to have a look at these images. And if you may be wondering, who's that guy? This is not an Oracle official product. Well, that guy, his name is Gerald Benzel. He's my manager. He's an Oracle person. So we're doing this on the side for the time being. It's our hopes that what we're doing here on the side will eventually be added to the official images. So don't worry, everything is still working correctly. Oracle people know. If you need previous versions before 23, we have support from 11 up to 21 with these images as well. Again, available for free. You don't have to pay a license. Just use it if you need it. Why I'm talking about Docker? Because you probably have heard about test containers. Who doesn't know about test containers? Okay, just a few hands. So just a quick reminder. When you are doing some kind of test cases and you need to test out with external services, we're talking databases of Kafka or RabbitMQ, some stuff like that. It's quite troublesome to tell the IT person, hey, can you provision that particular software for me? And then like 3 months later, you get the wrong version. And you have to do it again and again and again. And once you have it, you have to take good care of that because no one else should have access to it while you're testing, because your test environment will probably not be the one that you need. It will be much, much better if we can have that test environment closer to our test cases. Well, test containers allows you to set up Docker containers right next to your JUnit test case. So if you can use the real dependencies, just use test containers. There are many modules provided by test containers. There is the Oracle free module that allows you to use the latest versions of the database that provides access to this JSON Relational Duality View that we're talking about. So, okay, now let's go with the demo. Okay, that's before. So we still have some time. Let me showcase this. Okay, so I have here a Micronaut application, but I'm pretty sure that most of you know Spring or Quarkus. The good thing that I like about these frameworks is that even though we may be using different annotations, the basic idea, so what we want here is to map, I'm still here, I'm going to use a regular ORM, Spring calls it Spring data, Micronaut calls it Micronaut data, and Quarkus uses a completely different approach for this. But basically, you define a set of entities that will define your model, and each one of these properties, each one of these fields, will be mapped to columns. You may or may not have validation using the beans validation specification or some other annotations. That goes besides the point. So we have a handful of models here. So we have a class and a student and a teacher. It's very similar to the speaker session attendee model that we saw before. For these classes, similar to Spring data, we have the concept of repositories, which are basically interfaces that give you access to the CRUD behavior that you expect. So you can grab, you can get a new object. Well, I mean, you can get an object, you can create, you can save, you can store, you can find by the different properties, right? So Spring data has it, Micronaut Grail, you have this one before. Okay, that's not surprising. This particular application, again, because we're storing data in a relational model, these are the relational tables that we have. We have one table for each one of these elements. We have some frame constraints so that we have the data, we can ensure the data integrity within our model. But we also are going to have the definition of JSON relational duality views. I mentioned that we have two formats. You can use a JSON format like this, or you can use a GraphQL format like this one. It's depending, it's up to you. In the end, we will have one JSON relational duality view called a student schedule, and another duality view called a student DB. And we can send documents to the database or retrieve documents through these views. The application that I have here, where is the code of the applications? Right here. Because I'm running on a Docker container, yeah, I don't care if you look at this username, if you try. And we're just connected to a regular database that I'm running on Docker. Perfect. We have a controller. Because it's a very trivial REST application. The thing that this thing will do is we can find students by ID, or we can find them all. Notice that what this call is doing. The student repository, give me everything. And what is this method? Let's dive into this one. Inside our repository object, we can define as many functions that we want. And this particular one simply says, select data from that duality view. And this will give me a collection of JSON documents, one for each student that he has found. Just like that, we can also have additional settings. So I know that if you follow the repository path exposed by Micronaut or these basic finders and getters and delete and update, wanted to have my own way to find an object by an ID using the relational view, or find all of them using the relational view. I can also mutate, or I can also delete elements through the duality view by sending the right amount of data. I know there's a little bit of SQL here. In the future, likely someone will build some sort of helper deal with of our JSON view. So I'm going to run the application now. Let's run into the terminal, and let's make this a little bit bigger. Here we go. It's funny doing this with a hand mic. So the application is running right now, and there are a couple of things that we can look at. For example, we can query for the list of all the students. And this is the set of JSON. If we filter those through JQ, it looks a little bit much better. So this is a transformation that the database is giving you from that related data. If I select data from student DB, so that is my relational view, I get the set of all the documents. If I say select start from a student, which I believe that is the name of the relational table, I get the relational data. So that thing that I have on the bottom has been represented using the document. So what if we want to create a new one? Let's say, I have this, let's put DevOps, and the average grade will be 9.0, and this person would like to learn. All right. Let's go into the IDE, and let's run query. We got a new object, ID 4. Let's select from the relational view. And there is, but what application was a data true, but that data is relational. So now we query, can get that out. We get all students back again. There should be somewhere. There should be our ID 64. Not sorted. There is a new object. So this basically, there is no more complexity other than this. You should simply send documents to the database, and it will do the right thing. So gonna look at our controller. If we wanted to update one property of our document, this is how we will regularly use our ORM. We'll have to find the object by some property, likely this will be an ID. Once we have that object, then we mutate it using just regular Java means. That's what we would like to have an ORM, just using our programming language. Then update it, so this will do the mapping from the Java object into some SQL sentences, and then just return the object. That will eventually be mapped into JSON automatically, just because that's what the framework does. But if we were to update the object or the rows through the JSON duality view, we can take those numbers as they are, and then just insert that information through the JSON duality view. And if that JSON duality view return more than one entry that has been updated, then we can retrieve that value, and this value will be automatically mapped as a JSON object. Why? Because we're doing this. But instead of doing this optional student, we could simply have done return a string, in which case the JSON that has been retrieved from the database is going to be sent directly to the client without any additional transformation. So now you are in the driving seat. You have the choice. You could continue using the ORM or go one level down with SQL or some other sort of mapper, or use also the JSON relational duality view to get access to those documents. You could transform those documents if needed be at the application level, if you need to do some sort of additional post-processing of the data, or just once you have that document, just send it directly to the client. On the way back, just take that document, say, here's the way that we can create one new object using regular ORMs. Again, it's just regular Java code. It's not really that complicated. Or just take that JSON payload and send it directly to the database. Someone will be thinking, hold on a second, what about SQL injections? Is it safe to just take raw payload and send it directly to the database? It is safe. Why? Because it's thanks to this view that we have here, the database will check first, are you sending me a JSON document? Is a syntactically valid JSON document? Yes? Okay, so I'll continue. No, you're sending something else. Okay, I'm going to discard it and fail with an error. If it's a syntactically valid JSON document, now it has to search, does it match that particular semantic definition of a view that you specified? If it does, it will do the right thing for you. If it doesn't, it's going to fail. So you'll still be safe. You shouldn't be needing to do any kind of investigation to what happened, because the data would not be touched. All right. So I know with all these things that I have discovered, and many things that you will discover today and that we'll be listening to, there are new techniques, new technologies, new tools that sound like, oh yeah, I want to try this. And then you go back to your company and to your teammates and say, not really, because we are busy, because we have deadlines, because I don't understand, because of many reasons, right? Don't be discouraged. Try these things that you see today. Do proof of concepts. And once you're ready, do a presentation to your teammates and to your managers. There are reasons why we as vendors are producing these kind of technologies, because we have understood some of the problems. We are talking with you people so that we can give you better answers and better solutions. So it's worthwhile investing your time in learning and teaching about these particular technologies. We have at Oracle many different options for you to learn from our stuff. The first link is quite important. It lists a lot of free resources, not just the database that I showcased today, but there are so many other things that Oracle produces for free, not just for the database, but also for Java, for Linux, for Kubernetes, for the cloud, for many other things. And if you want to know more about the specific features of the database, we have the second link. And we also have tutorials and blog posts and videos, so many other ways that you can get in touch with the technologies that we are producing. One more reminder, the database that you saw today is available for free. You can use it in testing, in development, in production. We have the on-premise version that you can run on Docker as well, or you also have access to the cloud version, which is the autonomous database. Okay, so with that, thank you very much for your time. I still have a few minutes for questions.